right, so I'm going to pull up a spreadsheet and I'm going to make a a frequency distribution. And y'all follow along. Y'all go ahead and start working on it. And I want everything. I want the mean, median, mode, range, mid-range. I'm sorry. The mean, the variance, and the standard deviation. Also the class width, class boundaries, and the midpoints. Of course, you're going to have the midpoints to do the rest of it. But let's start with a lower class limit and an upper class limit. I'll make this bigger in just a minute. Let's go with 20 to 24, and then 25 to 29, and then 30 to 34, and then 35 to 39, 40 to 45, 44, and then 45 to 49. And then your frequency or your head count is 1, 2, 5, 6, 2, 1. All right, I'm going to make these bigger and get them centered, and I want y'all to start working. I'm going to give you 5 minutes to do as much as you can in 5 minutes. It is 8:17 right now. 8:17. So at 8:22, we're going to start everything. Can everybody see those okay? Still not big enough? How about that? Can you see those?
That's good.
Thank you. And centered. And the top row is bold online. I did have a question, and the reason I asked this question is because my son took virtual classes last semester for District 5, and y'all are in different districts in District 5. How does what I'm doing virtually compare to what y'all have done virtually in y'all's district? Is y'all's virtual classroom like this, where the whiteboard can come up and the spreadsheet can come up, and yes or no? Anybody had a virtual class? Nobody's had any virtual classes within the district last semester?
It's the same.
I'm sorry, what?
It's the same as last year, but this year they're not doing like virtual classes. They're just giving their work on Google Classroom.
And they're not giving any explanation?
No.
That's not virtual classroom. That's an online class. See, the districts are scrimping. The districts are not doing what they're supposed to be doing. District 5 sure as hell didn't. They had a cluster. It was the biggest cluster I've ever seen virtually. I mean, my son might as well have just been taking an online class at a college. Anyway, I just wondered. So they don't give any explanation, no whiteboard, no spreadsheet, no anything. You just work on problems, and if you understand it, fine. If you don't, you got to find a way to understand it. Yes or no?
They might give videos, but I don't know if they all do.
Are they the teacher that's doing the videos, or is it the book and the publisher?
I think the teachers give videos.
Okay, well, that's good. That's better. Okay, well, I was just curious. And it's 8:23. I gave y'all an extra minute. Standard deviation is equal to the square root of the variance, or the variance raised to the 1/2 power, or the variance raised to the 0.5 power. Now, I'm giving you these formulas again because I know probably, let's see, out of 15, probably 5 of y'all wrote these down. The rest of you didn't. Maybe 10 of you, I don't know. And these are what you got to fill out. So we already have F. You got to excuse my voice. I think it's going. I don't know if it's a sinus drainage or what. You got F is given to us. We don't need to do anything for F. It's given to us. N, we got to calculate N, and somebody tell me what N is. The definition, not the number. It's what? Say it one more time. What's the definition of N? Thank you, Miss Jarrett. And that is, I know you're not supposed to talk or communicate with me. The rest of the class is going to jump on you, but I appreciate you stepping out. Thank you. And there. I got 17. What'd y'all get? And that is N. Y'all get 17. I'm turning on the chat so I can see it. Yeah, good. All right. Thank you, Mr. Hamby. All right. So now we've got N. So let me go back to my handy dandy. Now, a lot of you are saying, well, why is he doing all this? Why is he highlighting everything? And why is he? Because I'm trying to show you the easiest way to do this by hand. And that's why you do everything first on the spreadsheet or the calculator or your paper, and then you plug everything in. So now I need X. That's my midpoints. So first I got to get my X, which is my midpoints. So I've got to go and get my class boundary or class width. So let's go ahead and do that. Class width is 5. Class boundary, let's see, 2019.5. And I'm going to add, no, I'm not, why is it doing that? There. Let me highlight these right quick. There. Equals this plus this F4. And I'm going to copy that over until I get to 49.5. And one more. There. And there is your class boundaries. So we're going to find X. First, I got to find the midpoint of these two. So equals parentheses this guy plus this guy divided by 2. I'm finding the midpoint of the two upper class, lower class limits. And then I'm just going to add my class width to each one of those. So I'm going to add D2 plus this number and alternate F function F4. And I'm going to copy that down. And that should be my midpoints. So y'all check, make sure I didn't make a mistake. Let's make sure we keep our foreheads and eyes so I can see them in those ceiling fans, please. I don't know what it is with y'all. This is what I see right here. I don't understand that. Come on, be proud of yourself. You look good. All right. So what's next? Well, let's go back to the formulas. We got X now. So let's go back to the formulas. And another reason I do this is because I'm trying to teach you to read the formula, because some students, they will not read the formula. They'll just go to the teacher and say, I don't know how to do this. So there's X. And there's X. And we need X squared. So let's go back. And X squared, I think y'all can handle that. Raised to the second power. And copy that down. And now we're ready for F times X and F times X squared. And I'm going to highlight these green because F is already given. So that's green. And I'm going to highlight these yellow because we had to calculate those. And now we're going to do F times of X, and these are our formulas, so I'm going to highlight those and give them a color of aqua because we had to highlight those. We got to calculate these. So F times X is equal to F times X, and copy that down. And let's go ahead and do a sum. And F times X squared. And I want you to check my numbers because I want each one of y'all to check to make sure that you have all this done on your notes so you won't forget what to do when you're at home. And there are our totals. So pull up my handy dandy whiteboard. And what is our mean? We take the F times X, the blue. What did I do with my blue marker? There it is. 589. And we divide that by 17. See how easy this is? This is not hard if you do it the way I show you. So the mean is equal to 589 divided by 17. Y'all check my work and tell me if you got 34.6. Give me a thumbs up. Good, 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 good. All right, so let's go back to our handy dandy whiteboard. And let's fill out the second part. This is 17. F times X squared. Summation 21013. This number has to be a BA number. Okay? Why? Because you're subtracting this number and you can't take the square root of a what? You can't take the square root of a what?
Negative.
So therefore, this number right here has to be a BA number. So this one will not make it a negative. So if you come out with this number being bigger than this number, you know you've done something wrong. And that's going to be the summation of F times X is 47. So that's going to be, 589. That's going to be 589 raised to the second power over, and I think y'all can handle this, 17 times 16. Now all you got to do is plug and chug. So variance is equal to N times the summation of F times X squared minus this guy raised to the second power. My eyes are watery, and I'm sorry, I can hardly see as it is. And that's going to be multiplied by 17. Sorry, excuse me. 17 times 16. I bet you $1 when I get on that track hoe today, I'm going to be wearing daggum face mask or something. And that's what happens when you ride your hoe and you're not protected. You got to make sure you're protected when you ride your hoe. Oh. Half of y'all don't even know what a track hoe is, do you? Anybody? It's a BA piece of equipment. Unless you get one of those little ones that you can put on the back of your truck. Variance. Okay, I don't know why that did that. Variance equals, okay, check your numbers. 17 times, I'm not going to have a voice tomorrow. There's that BA number. Minus, and that number has to be bigger than this number. 589 raised to the second power. And it is bigger, so we're good. It's not going to be much bigger, just a little bit bigger. Over equals 17 times 16. Now check my numbers. Give me a thumbs up. Everything look good? Good job. Some of y'all going to have nice offices when y'all get in the career world. Some of y'all that don't communicate, y'all going to be in a closet where the janitor is. And they're going to take a piece of plywood and put over the mop sink, and that's going to be your desk because you don't communicate. Okay, so the variance equals this guy minus this guy over this guy. And the variance is equal to this guy divided by this guy. What'd y'all get? Did y'all get 37.86? Good job. Y'all are winners. So variance is equal to that number right there. And of course, the standard deviation is equal to that number raised to the 0.5 power. And there is 3 test questions right there. And I'm going to highlight these burnt orange. And there is 3 test questions right there. And right here, sorry. Here is 3 test questions right here. There's 2 test questions. And here is another test question now that we're done with the problem. This right here is another test question. So there are your 5 or 6 test questions for this section. Now, you may not see a lot of homework, okay? Hold on, Ms. Newsom, I'll answer that question. You may not see much of these in the homework. All you have to do is make them up. So you can use these lower class limits and upper class limits, and you can just change these numbers right here. I'll show you how to check it in your calculator in just a minute. Okay? So with that being said, when do you know where the decimals go? Well, as a general rule, you want to take your decimals at least to the 5 or 6 digit through the calculation. Okay, just like this right here. And then at the end of the problem, before you type in your answer, that's when you round. And you look at the directions, and it'll say round to the 10th or the 100th or the 1000th. But see, you're taking it to the 5th or 6th digit through the calculation, so you got it covered. You never, ever, 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 ever say, okay, the mean is 34.64, so I'm going to make it 34.7 or 34.6. You don't do that in the middle of the problem. You carry everything out to 5 or 6 digits. And then at the end of the problem, when you're fixing to type in your answer, that's when you round. Does that answer your question, Ms. Newsom?
Yes, sir. Thank you.
Okay. All right. So that's, I give y'all, I think we did 2 or 3 frequency distributions. That's good. So now let's move on to 3.1 and 3.2. 3.1 and 3.2. Tendencies to the end. Tendencies of center. In statistics, everything revolves around the what? The center. Everything. So if you're doing any kind of project or any kind of research, it all depends on how the numbers relate to the center. And in 3.1 and 3.2, y'all know most of this stuff because you've all done it in some math class in the past. The mean, the median, the mode, the range, the mid-range, and the variance, and standard deviation. Well, here we've already done some of that. No, this is not with a frequency distribution. This is with data, like your test grades. You know how you average up your test grades at the end of the semester? That's data. Okay? So, how do you find the mean? Somebody tell me what you do to find the mean of your test grades. Y'all know, all know how to do it. So I just need somebody to communicate. You know, like in a career or a relationship, you always want to communicate, you know. There's going to be a lot of divorces in the future.
Add them all up and divide by how many there are.
Add them all up and divide by n. Everybody agree with that? Add them all up and divide by n. Whoever that was, thank you very much. Hope you don't get beat up after class. Going against the creed of the class. You're not supposed to communicate. Median. What is the first word? What is the first thing you think about when you hear the word median? And if you say something mathematical, you're lying. You don't think mathematically.
Middle.
Middle. You're the middle of the road. The median in the middle of the road. So this is a calculated middle using n middle numbers. If n is even, you got to find the two middle numbers. Add them and divide by what? 2. If n is odd, you just find the middle number. So that means you got to have all these things in order. That means your data has to be in order before you do 3.1 and 3.2. They have to be in order. What does the mode represent? The number that shows up the what?
Most.
Number that shows up the most. Thank you very much for your communication. Can you have more than one mode? Yes. But they all have to be the highest number. You can't have one show up 2 times and one show up 3 times and say they're both modes. The number that shows up 3 times is the mode. Everybody understand that? Even the foreheads? Foreheads understand that? Range. Anybody know what the range is? Anybody know what the range is? The highest minus the what? Minus the lowest. I'm coughing, but at least I don't sound like I'm in the Marlboro Club or the Camel Club, whichever is the most popular nasty thing to smoke now. So what is the mid-range? Mid-range is another word for midpoint. Anybody want to take a stab at it? What's the formula for the mid-range? Anybody? Highest plus the lowest divided by 2. The variance is equal to the summation of x minus x bar squared over n minus 1. And the standard deviation is equal to the square root of the variance. Now we're going to do these all together because I feel like if I teach you problems all together, then you can pick out what you need for a test or a homework question. And like I said, most of you are probably more familiar with this than you are with the frequency distribution mean and standard deviation. So let's go to it. Let's go to the spreadsheet again because I can get everything on one sheet. And here are my X's. I'm going to use test scores. Okay. Let's go with a 72, a 78, and these are in order by their score, not when you took them. 78, 82, 85, 92, 95, and 95. All right. Now I want you to do, I'm going to give you about 3 minutes. I want you to do as much as you can with those 1, 2, 3, 4, 5, 6, 7 numbers. Go ahead and do as much as you can by hand. I don't want you to, and any third grader can use a calculator. I don't want you can use a calculator to help you do it, but you know, typing them in and finding everything at one time, any third grader can do that. I don't want you to do that. I want you to tell me or figure out what you can do by hand, what you remember. So take a couple of minutes and do that. All right, so here we go. N is equal to 7. So it's an odd number. So that means that guy right there, that's the median. I'm going to go over here and say mean, median, mode, range, mid-range, variance, and standard deviation. So the mean, we're going to add up all these numbers. And divide by 7. And I got 85.57143. Thumbs up, down. All right. Median. We already got that. That is right there. Mode. I really don't care about the mode, but it looks like 95 is the mode. Range is equal to the highest minus the lowest. And the mid-range is equal to the highest plus the lowest, or the lowest plus the highest. It doesn't matter because addition is commutative. Divided by 2. Now let's talk about what's important. That's important. Let's make that green. That's important. That's important. And this is important. What do you mean important for the test, Hubert? No, important for the rest of the semester. You're going to see these things over and over and over. The green. You're going to see those over and over and over. So let's find the variance. Let's go back to the formula. Somebody tell me what we need to do first. Remember, please excuse my dear Aunt Sally. So we got to do what's in the parentheses first, then exponents, and outside the exponents. So what do we do here? What does that mean? X minus X bar. What are we actually doing here? I need you to give me a sentence. Means communicate. Come on, you can do it. What are we subtracting from what? Can y'all not read that? Can y'all see this? X minus X bar. What's X bar? Okay. None of y'all know what X bar is. Okay, X bar is the mean. X bar can be written as, or the mean can be written as X bar. It can be written as, let me write this in red. I bought new pens. I got black pens and I got red pens. I keep Amazon in business. X bar, mu, average. Those are all different representatives of the mean. X bar, mu, average, mean. Everybody got that? So now what are we going to do right here? We're going to subtract the mean from each one of the what? Each one of the test scores. So let's go do that. X minus X bar. D2 minus the mean and function F4. And copy that down. Give y'all a second to do that in your calculator and your sheet of notebook paper. Take your X and subtract 85.57143. And you should feel good about yourself. Now, somebody look back at the formula. What are we going to do to X minus X bar? We did parentheses, please excuse. So what are we going to do to X minus X bar? Okay, it's only 2 words. What?
Square it.
Square it. So we're going to take those numbers and we're going to square them. X minus X bar, quantity squared. That's going to make all of them positive. That's what it's supposed to do. I'll give you a second to write those down. And somebody tell me what we're going to do to X minus X bar after we square it. What are we going to do? What does sigma mean? Sigma means what?
Add them all together.
Add them all together. Good job. And that is the numerator to your formula. So I can go down here on my white sheet, and I just do this to bring it home. 473, 7143. $473, 4713 divided by 7 minus 1 is 6. So that right there is your variance. So I'm going to do that on the spreadsheet. So my variance is going to be equal to this guy divided by parentheses 7 minus 1 close parentheses. I got 78.95. Thumbs up or down? That's what y'all got? And now, of course, you just raise that to the 0.5 power. H28 raised to the 0.5 power. I got 8.8855. So. Now, let's talk about what we found. Does anybody have a nickname or a layman's definition for the standard deviation? Anybody? Anybody that's had it before, know what it is, or in layman's terms, not mathematical terms? Anybody? It's how the distribution is spread out. Big number Good. Small number? Good. How do you know what's good and not good? Well, you look at the, well, you'll see in just a second. What else do you notice? Well, look at the mid-range, the median, and the mean. What do y'all notice about those three numbers? That means I want somebody to say something or type it in. What do you notice about the mid-range, the median, and the mean? Well, let me do this. I'm going to change these numbers around. They're close together. Good, Miss Newsom, that is correct. Let's look and see what happens when I change some of these numbers. Let's go with a 58, 107. What happened to my standard deviation? Did it get bigger or smaller? Okay, I'll do it again. Okay, there's my numbers. I had 8.85. Thank you, Miss Newsom. And then when I change those two, it got what? What does that say? The standard deviation says you got some numbers in there that are not in line with the other numbers. That's what it says. Look at the mid-range, median, and mean. What happened there? Not much. But what happens when I change this to a 78? I change this to 95. And then I change, I don't know, change this to 90. And change this to 80. Excuse me. Did my standard deviation go up or down from 8.8? It went down because the numbers are closer. So what does this say? This is important because I guarantee you some of y'all have went through a whole probability and statistics and never saw this. Okay? What does this mean? If the mean, the median, and the mid-range are close, that means the spread or the standard deviation should be low. When the standard deviation is low, that means that you have tight data. That means that your data is close together. When the standard deviation is high and the numbers aren't close, that means your data is loose. That means you got a lot of variation in your data. So let's say you had a bad day and you make a bad grade on the first test. So let me let you write that down. Everybody got it? I still see a couple of y'all writing, so. Of course, some of y'all hadn't wrote anything, so I don't know if you're writing this stuff down or not. So I don't know. So what if I change this to 0? Let's say you flunked it. Let's say you made it 21 on the first test. Look at those numbers now, 58, 90, 79. They're not matching very well, are they? And look at the standard deviation. This says you got a number out of whack somewhere. And of course, if you add 100 on here, you see it goes out of whack even more, 60 versus 90 versus 80. And I guarantee you there's people in here that's never been told to put those four numbers working together, those three numbers, compare these three numbers, and what does that mean for that number? Okay, if these numbers are close, this number will be small. If these numbers are way out of whack, this number is going to be big. So let's change it to 80, 82, 85, 87, 88, and 90. How close are your numbers? 85, 85, 85. So that means we're going to have a what standard deviation? A low standard deviation. See what the numbers tell you? That's what statistics tells you. You got to know this stuff, okay, in order for the numbers to tell you what's going on. Let me ask somebody, who in here has had a probability of statistics class before? Anybody? Raise your hand. Nobody has had it. I thought they'd like give it out like candy. I thought they make y'all take like probability and statistics in high school. They don't? Well, that's a good thing.
We took pre-cal.
You took pre-cal. That's a good thing. Take as much pre-cal and calculus as you can before you graduate, because that's what's going to matter when you get your entry exam. That calculus and pre-calculus is going to help you a whole lot more than this will. Okay, so make sure you, especially if you're going into science and engineering. All right. So anyway, to make a long story short, if these numbers are close, this number is low. If these numbers are different, this number is high. What else can we learn? Well, 5-number summary. What is the 5-number summary, Hubert? And I'm fixing to tell you. And I think this is 3.4, I think. I'm not sure. I think it's 3.4. 5-number summary. It consists of the mean, the first quartile, the second quartile, the third quartile, and the max. Now, the first quartile is also called the 25th percentile. The second quartile is also called the 50th percentile. And the third is called the 75th percentile. Think of it like a fuel gauge. On the left, it's what? What does your fuel gauge say on the left? Empty. 0%. And then this right here is what? Quarter of a tank. This right here, half a tank. This right here is 3/4. And this right here is full. Okay, so they're asking you, what numbers represent the first quartile, the second quartile, and the third quartile. That's what they're asking you. I bet you that's the first time you had a teacher tell you to look at a gas tank before. All right. The min, if you miss the min and the max on the test, don't tell anybody, because you're just hanging a sign around your neck that says, I'm not writing ahead. Okay? The min on this last problem was what? Let me move it up, sorry. Well, if I could work my computer, I'm about ready to quit. The min is 80, and the max is 90. We already have the second quartile. Does anybody know what it is? It's 85. The second quartile is always the median. So now all you got to find is the first quartile and the third quartile. How do you do that? Well, you go back to your list of numbers. I hadn't decided. I may put 3 in there, Miss Ferguson. I may put it in there. I think 3.3 is the frequency distribution, which that was in chapter 2.2 and 2.3 in the old book. So they must have moved it. So I'll get that straightened out eventually, okay? I'll give you some homework in 3.3. Probably not a lot, probably like 5 questions. Like, just do what we did. Find the mean and the standard deviation and the variance of a frequency distribution. That's it. Does that answer your question, Ms. Ferguson? She's not listening. She must be listening to music. Miss Ferguson, did you hear me? Thumbs up or thumbs down?
Yeah.
Okay, are y'all paying attention? I hope y'all are. I hope y'all not going Crescent High School on me, I hope. All right, so how do you find, well, how many numbers are above 85? Somebody tell me, how many numbers are above 85? 3, Hubert. So you just, since 3 is odd, thank you. Since 3 is odd, you just find the middle what? The middle number. And that is your first quartile. So 82 would be the second quartile. And here is, you got 3 numbers above 85. So 88 is your third quartile. So you find the median of the above numbers and below numbers. You find the median. And that's how you find the 5-number summary. Now, how do you do the box plot? Well, here's the box plot. First thing you draw is a number line. So to do a box plot, first thing you do is draw a number line. With 3 lines. Here, here, and here. This is the min. This is the max. And this right here is the mid-range. So let me go back to what's my mid-range? 85. And this would be 82.5. And this would be 87.5. You start graduating. This would be 81. This would be 84. This would be 86. This would be 89. Okay, and graduate. Graduate the number line. 2. After you graduate the number line, you just plot these 3 numbers. So 82, I'm going to circle it in green. Sorry. 82 is going to be right in here. 88 is going to be right in here. And 85 is going to be right in here. And there is your box plot. That's how you do a box plot. But to answer your question again, Ms. Ferguson, 3.3, y'all already know how to do. Okay, it's nothing new. So when I assign the homework, I'll put it up there. It'll be called 3.3 homework. You already know how to do it. Or you've already been shown how to do it. All right. One more thing I want to show you, and it's a very, very important because it's going to follow this information right here. You remember when I told you that this information right here is going to follow you through the whole semester? Well, so is this. And I think it's on page 129 in your book. I don't know where it is, but it's called the Empirical Rule. And I'm going to write it in red because it's very important. The Empirical Rule. And I bet I don't have, I bet you I done gave it, let's see. Crap. Okay, let me get.
Priority 1 message coming in on secured channel.
Give me a second. Hold on. I've got some printouts, which I would highly suggest that y'all go, and I know that only 3 or 4 of y'all is going to do it. Here's one. That right there is the empirical rule. So go ahead and draw it. That's the percentages. Now, I will send you, of course, like I said, only like 2 or 3 of y'all is going to print it out, but I'll send it to you. Let me send it in the chat. Because I've still got it on my computer. Where did all that calculus come from? Okay, let me go to downloads. We do a search for curve CURVE. Well, I'm not finding it right now, so I'm going to show it to you. Let me just show it to you. Go to your Google and pull up normal curve empirical rule. And there it is right there. Go to images and pick one that's got the and then of course you would save it, copy. Now I'm gonna do this for y'all because I know that 2 or 3 of y'all will do this. Make a word processing document and put it on that word processor. Change it layout to landscape with no margins and Control V. And there it is. Okay. Now, a lot of you are saying, why? Why do you need to print it out? Well, this is what I would do. I'd print out a few of these. And then I'd print out some of these with 4 on each page. And then I'd print out some of these with 2 on each page. Well, if I can find one with 2 on each side. Oh, forget it. I had some with 2 on each side, and now I can't find them. Here's one. And there went my mouse. So there's 2 on each side. Now, why am I telling you to copy these and make copies? Why am I telling you this? Because on every homework problem you do from here on out, you're going to be drawing this curve. And some of y'all are going to get tired of drawing it. So I would highly suggest that you learn the empirical rule. Now, what is the empirical rule? 95% of the population, write this down, 95% of the population will fall within 2 what? Standard deviations. "95% of the population will always fall between 2 standard deviations." And I need to stop right there and before some of y'all start convulsing. Now I can't put my mouse back together. It's a conspiracy. Every time you drop a mouse, it freaking bust all to pieces. Okay. So I've already taken the roll, so you're good to go there. So everybody needs to start working on 3.1, and I will put 3.3 up a little bit later. And actually, this right here is 3.4. So some of y'all can move ahead if you want to. But 3.1 and 3.2 is what you're responsible for Thursday, okay? So make sure you get 3.1 and 3.2. If you want to play a little bit with 3.3 and 3.4, knock yourself out. And I will see y'all Thursday, okay? All right, y'all have a good day. Oh, there's some people must hate this class. I ain't kidding you. They must hate it.